All right, so today we're going to be looking at sequences and then series. So some definitions to get us started off. First, um, you know, what is a sequence? Just any list of numbers is a sequence. So this is an example of a sequence. We got 1, 1/2, 1/3, 1/4, 1/5. You guys are clever. What would be the next? What would be the next thing to come in this sequence? Well, 1/6, 1/7, and that would go on and on and on. And this particular sequence is called a harmonic sequence. It's a special sequence, but we're just going to be looking at sequences in general. And so a couple things that we should be familiar with. First, the domain. The domain of a sequence is the set of all positive integers. So the domain is looking at 1, 2, 3 onwards. And when we talk about a sequence, uh, we write it as a sub n, which is the same thing as f of n. And each value in that sequence, so for example, one of my values is 1/4. That's one particular value in that sequence, and that's called a term. So each individual value is called a term, and we write that as a4 or f of 4 because it's our fourth term. That's 1/4. So, if we wanted to express this harmonic series above, or the harmonic sequence above, in terms of f of n, what would be an equation for that? Well, I think pretty clearly you can see that the equation would be f of n equals 1 over n. For the domain, given the domain that n must be a positive integer, 1, 2, 3, 4, 5, 6. So like when n is 1, a of n, sorry, a of 1, you put 1 in for n, 1 over 1. A of 2, you put 2 in for n, 1 of 2. So uh, a of 15 or a sub 15, that's our 15th term. That's our 15th term. Get used to the vocabulary. Would just be putting 15 in for n. Would be 1 over 15. Okay, so that's what a sequence is. Again, a set of numbers, an ordered list of numbers. So what we want to do is think about, well, what happens when n gets really, really big? Will the sequence, will the nth term, so in other words, does the nth term converge? And in order to do that, we need to think about, well, what happens when n gets really, really big? In other words, we want to evaluate a of n when n gets huge. So the limit as n approaches infinity of a sub n. Looking at this particular problem here, does that nth term converge or not? So we replace a sub n with n over n plus 1. And we say, does this converge? Does it not converge? Well, if we put infinity into the top and infinity into the bottom, we get infinity over infinity, so we could use L'Hopital's rule and take the derivative of the numerator and denominator to get 1 over 1. That's, again, using L'Hopital's rule. And we see that as n gets close to infinity, our value gets close to 1. So that implies that this converges. What about the next one? Well, in the next one, we have this very familiar, or what will become familiar, numerator, which is -1 over n. And remember, n is the domain of n is all positive integers. So the effect of this this -1 to the nth, when n is 1, we have -1 to the 1, which is -1. When n is 2, +1. When n is 3, sorry, when n is 3, again, -1. When n is 4, +1. So uh, this value here makes the sign oscillate between positive, negative, positive, negative. But we still can talk about its convergence. So, if we think about this, the limit as n approaches infinity of -1 to the n over n, well, the numerator is just plus or minus 1. So we could write this as plus or minus the limit as n approaches infinity of 1 over n. And once we get there, we recognize, oh, well, this is just plus or minus 0, which is 0. So the sequence b to the n converges. And to do the last one, if we look at what happens to this, well, this is an interesting sequence. The limit as n approaches infinity of -1 to the n. Well, that's just going to go +1, -1, +1, -1. So while the values stay around +1 and -1, it never converges to an actual number. It just flip-flops between these. So this is said to diverge. Okay, and that's nothing new, but we're just adding on the sort of the vocabulary. We're talking about sequences here. All right, so one thing that you may want to do, and this is a lot of words here, so this is up here in case you want to refer to the PDF later, or you could just look in the textbook. But the key thing is that if we want to plot a sequence like that harmonic sequence that we're talking about, 1 over n, we can use our graphing calculator, but we just need to make one little switch. So in your graphing calculator, we need to take it out of function mode. So if you turn your calculator on and you go to mode, and we go down here, this is function mode, parametric mode, polar mode, and then sequence mode. So we want to be in sequences because we're talking about sequences. Okay, well, once you do that and you press your y equals, this is going to look a little bit different. So what is this saying? Well, n min is saying, what n value do we want to start off with? So we're saying we're starting off with 1 and it increments 2, 3, 4, so every positive integer. And the next line, that's where you put in your function, your sequence. So it's 1 divided by, well, where's the n key? The n key is actually the same as the x key. And that's all you need to put in for this. And then we need to mess with the window a little bit. So if we press window, we want to start with our n being 1. Let's just look for 10 values of n. So we'll go 1 over 1, 1 over 2, 1 over 3, 1 over 4, and we want to plot what this looks like. Well, so let's make our, what do we want to do? Let's make our x min -1 and our x max 10. And the x min and the x max, that's really just looking at like n is 1, n is 2, n is 3, n is 4, but it's calling it x min and x max. And if we keep scrolling down, we know that our function 1 over n is going to go from 1 down to 0, because 1 over 1 is 1, and then as we increase n, 1 over 2, 1 over 3, 1 over 4, 1 over 5, it's going to get close to 0. So it's going between 1 and 0, our y values. So let's make our y values between -1 and 2. And now, we'll capture everything. That's good. So then we graph it. And what we see is what we would expect to see here. If we trace along, I've got the point 1, 1 when n is 1. 2, 0.5, because when n is 2, we have 1/2. When n is 3, we have 1/3. When n is 4, we have 1 over 4, 0.25. So this is plotting each of those points in the sequence. What you also might be interested in doing, if you go second table, so now, here are all the n values and the corresponding values of the sequence, which are called the terms. So we've got, when the first term, the second term, the third term, the fourth term, and it gives you their values. So this is a very helpful key. or a very helpful function, rather, of the calculator. All right, so we're talking about sequences, but where we're getting to, more important, more useful, is this idea of series. And what the series, when we talk about series, what that means is that you're adding up every term in the sequence, up to some fixed point. So the series, and I'm going to just rewrite what's here. The series is the sum, and this is the sigma notation for sum, from when n equals 1 up until n equals something. In this case, uh, let's just say n equals infinity. So that would be adding up every single term um, of a sub n, and that equals, my first term plus my second term plus my third term plus all the way up to my infinite term. And this sigma notation we write as s sub n. So it's this s being for the sum of all n terms. Well, let's see what that looks like. So if I'm given some sequence f of n equals n squared, and I want to find s of 3, or s sub 3, the sum of the first 3 terms. S sub 3 is going to be s sub 1 plus s sub 2. Sorry, not s. It's going to equal a sub 1 plus a sub 2 plus a sub 3. And then we can calculate those. So, a sub 1, that's just putting 1 in for n. So 1 squared plus 2 squared plus 3 squared equals 15, 14. And as n gets bigger and bigger and bigger, s sub n is going to get bigger and bigger and bigger because we're just, we're adding tons of numbers to it. Well, let's get a little bit more to the heart of what we're going to be doing. So what we're going to be looking at mostly now is what happens when a series gets smaller and smaller and smaller. So, sorry, not when the series gets smaller, but when the sequence gets smaller, when the terms get smaller. We want to look at, does the series converge or diverge? In other words, we want to know, as n gets huge, what's happening to s sub n? Does it just keep growing, or will it reach some fixed amount? Does it converge or diverge? So here we have s sub n, and it's written in sigma notation, and they give us a hint. They say, in order to answer this question, let's look at s sub 1, s sub 2, s sub 3. So s sub 1 we know is 1 over 2 to the 1, which is 1/2, and s sub 2, well, that's a1 plus a2, so that's 1 over 2 from before, plus a sub 2, which is 1 over 2 squared, and 1/2 plus 1/4 equals 3/4. And if we look at the next term, s sub 3 is going to be a sub 1 plus a sub 2 plus a sub 3. So we're going to carry this term again, that because 3/4 is that. So we have 3/4 plus a sub 3. Well, plugging in 3, we get 1 over 2 to the 3, which is 1 over 8. So 3/4, but I'm going to write that as 6/8 plus 1/8 equals 7/8. Let's just look at one more term, and I think it'll be clear. What if we look at s sub 4? Well, s sub 4 is s sub 3 plus a sub 4, which equals 7/8 plus 1 over 2 to the 4, which we can write as 14/16 plus 1/16, which is 15 over 16. And I'm going to pause this, but you should start to see what s sub n approaches. So we're going to start another video.